Let us now look at the concept of the second derivative. The second derivative is the derivative of the first derivative, which means we are going to apply the general rule for differentiation twice on the function. Let's demonstrate the concept of the second derivative using an example. Let's say you've been given the function y as shown, and you are required to find dy dx or d squared y dx squared, which is the second derivative of this function. Remember, we said to find the second derivative, you apply the general rule for differentiation. Remember the general rule for differentiation? It says if I'm given the function y equals to x to exponent n, to find the derivative or the first derivative, I simply multiply x by its exponent and then subtract 1 at the exponent. Now we've been given y equals to x to the exponent 5 minus x to the exponent 3 plus x minus 1. Now to find the second derivative of this, first we have to start with the first derivative, dy dx, applying this rule on each one of these terms. Remember, the derivative of a constant is 0. The derivative of x will simply be 1. Now, to find the second derivative, I'm going to apply the general rule for differentiation on the derivative. So that gives me 20x to the power 3 minus 6x, which is the second derivative of this function. Let's try another example to solidify this concept. Let's say you've been given the function f at x equals to 8x to the exponent 3 minus 7x, and you were asked to determine the second derivative of this function. What you do is to apply the general rule for differentiation once. When you differentiate this, you multiply x by its exponent. We already have a constant here, so it's going to be 3 times 8, which gives us 24, and then 3 minus 1, which gives us 2. X has an exponent of 1. If I say x multiplied by, if I say 1 multiplied by negative 7, it will still be negative 7. If I subtract 1 from 1, it will be 0. Any number to the exponent 0 is 1. So that's why we are simply left with 7 here. Now, I have to derive the first derivative in order to find the second derivative. So finding the derivative of this gives me 48. Remember, minus 7 is simply a constant, and the derivative of a constant is 0. Let's try yet another example. Let's say you've been given some function y equals to the square root of x plus 5x squared, and you are required to find the second derivative of this function. Remember that the general rule for differentiation does not provide for the square root of x. We need to standardize the square root of x to be in the form that we can use the general rule for differentiation. Let's simplify that. We know that the square root of x is the same as x to the exponent half. Then when we have this standard form, we can apply the general rule for differentiation once. We get y prime, and we have 1 half of x to the exponent minus 1 half plus 10x. Then we apply the derivative again, or we use the general rule for differentiation on the derivative to find the second derivative. That gives us 1 minus 1 quarter x to the exponent 3 halves, or 3 over 2 plus 10. Let us try one last example. Please feel free to pause the video and try this example yourself. Like in the previous example, The general rule for differentiation does not provide for a cubic root of some function. In order for us to find the derivative of this function, we have to use the laws of rational exponents to simplify this expression to be in the standard form. This is the same as 6x to the exponent 2 over 3. Then we can apply the general rule for differentiation once to find y prime, and then derive y prime to get the second derivative, which gives us minus 4 over 3 x to the exponent minus 4 over 3.